Let's talk about the radius of gyration of a tubular structure. That refers to a measure of a distribution of the mass from the tube related to its axis of rotation. For example, this is the tube and it has the axis of rotation as this one, and how much far this mass is concentrated from the axis of rotation. That's a measure of radius of gyration. That's a imaginary point. We can assume that this much distance this entire mass is concentrated, so that it offers the moment of inertia and stiffness. We can calculate it. So it is essentially the distance from the axis of rotation at which the entire mass could be assumed to be concentrated for the purpose of calculating moment of inertia stiffness. Radius of gyration R for the tubular structure is like given by R equals square root of I by A. I is the moment of inertia, A is the cross-sectional area. We can calculate the moment of inertia for the tubular or outer radius and inner radius using these formulas I and A, and then we can calculate the radius of gyration also. This formula allows you to calculate the mass, how the mass of the tube is distributed distributed related to its axis of rotation, and is using R as the radius of gyration. Okay, radius of gyration tubular structure refers to the effective distance from the axis of rotation at which the entire mass could be assumed to be concentrated. This concept simplifies the calculation of moment of inertia by treating the distribution of mass as if it were concentrated at a single point from the axis of rotation. The hollow tube is the distance. This gives us a measure of how the material is spread out in relation to its central axis. The larger radius of gyration indicates that the mass or area is distributed farther from the axis. That means, like, if it is radius of gyration is large, it seems like the mass or area is distributed farther from its axis. That typically results in higher amount of inertia or greater resistance to bending and rotational forces. In structural engineering, the radius of gyration helps us predict how a tubular structure will behave under forces like bending, twisting, compression. It's a useful measure when analyzing the stiffness and strength of the columns or pipes under load. Let's go through a numerical example and calculate the radius of gyration or outer radius and inner radius. And from that we can calculate the radius of gyration, moment of inertia. First step, calculate the moment of inertia using this formula. Just plug in the values. First calculate the power of radii, all these things, and now calculate the I, and then calculate the cross-sectional area. Substitute the given values and you can get the area as well. And once you get these two, and you can calculate the radius of gyration. It seems the radius of gyration is around 11.2 centimeter. So let's see one in small discussion. Tube. Here, Alex, I'm feeling like kind of out of shape. Can you explain how strong I am? How can I resist all those bending and twisting forces? Of course, let me explain something called radius of gyration. It's going to help us understand how well you resist these forces. So radius of gyration helps us to understand how well you resist these forces. And imagine you are a tube like this one and the hole in the middle. Imagine you are a tube like this and the hole in the middle. The strength of your resistance depends on how far your material is spread out from the center. From the center, how far your material is spread out from the center. That depends on that your strength going to lie on. That the more spread out I am, the stronger I am. Exactly. The radius of gyration is the distance from the center. We could imagine all of your mass is concentrated. The further the mass, the stronger the tube. And now let's calculate. The formula is simple. We need to know your moment of inertia and your cross-sectional area. From there we can get the radius of gyration. Moment of inertia area. What does that mean? What does that mean? Don't worry, let me explain. The moment of inertia measures how much mass is spread out and how far it is from the center. How far it is from the center. Your area is just amount of the space it taken up across your cross-section. First, you tube. Your amount of energy depends on both outer radii and inner radii. The bigger outer radii and more mass is far away from the center. The more mass is far away from the center. I see. So the bigger I am, more resistant I am to bending. Yes, that the distance where your all material is imagined to be located is the radius of gyration. It helps us understand how your strength and how much force you can handle. So when we calculate it using our outer and inner radii, we get your radius of gyration, which is the effective distance from that tells us how strong you are under force. So my radius of gyration helps me to stay strong when I'm being bent or twisted. Exactly. The bigger your radius of gyration, the stronger and more stable you are. I feel great now. Thanks to the radius of gyration, I know how strong I am. I'm ready for anything. That's the spirit. Now you are not just a tube, you are strong. Resist tube with the power to face anything, any force that comes your way.